Hello everyone, I'm Anusha with my team Anusha Raibagi, Manjula Meti and Sandhya will be demonstrating the project titled AI Enhanced Phishing Detection and Prevention, and the problem statement goes like to design an AI based tool that can distinguish between legitimate and the fraudulent URLs, preventing the access to the malicious websites. Here is some introduction to the topic. A phishing attack is amongst the most common types of cyber attacks. This type of attacks involves some type of social engineering where the attacker sends the fraudulent messages, tricking the victim into providing his credentials. AI based awareness has especially been found to be relevant in avoiding these attacks. AI based cybersecurity effective in preventing most type of attacks.
The objectives of our project are as follows. First, to develop a URL analysis system that can accurately detect fraud URLs. This involves creating a system that can analyze URLs to determine if they are fraudulent or legitimate. Second is to apply appropriate algorithms to achieve solution to phishing attacks. Phishing attacks involve tricking users into divulging sensitive information. To combat phishing, the system needs to employ algorithms that can effectively identify URLs. Third, to reduce the response time to URL threats by implementing real-time alerts. Time is crucial when dealing with URL threats as fraudulent URLs may spread rapidly. So this objective mainly focuses on that. Fourth is to evaluate the effectiveness of a system in fraud attacks. After developing the URL analysis system, it's essential to check if it is working as expected or not. This involves evaluating metrics such as accuracy, precision, etc. to determine how effectively the system identifies fraud Next URLs. Is the methodology. Here we have two actors, namely the user and the database. First, we have input dataset. In input dataset, we have a set of URLs and a set of features involved. Next, the user now enters the URL. After entering the URL, the system prepares the URL for processing, which may involve steps like removing or converting the URL into standard format. After that, we extract the features. Features are being extracted from the URLs. This could be the presence of certain keywords or like length of the URL. After that, we apply heuristics to this. Heuristics are applied to extract the features. They are basically a set of rules that is used to make classification decision. Next, we classify the URL. Based on the extracted features, we classify the URL whether it is a malicious or a legitimate one. Next, we display the result to the user based on the result.
Let's dive into the implementation part. Here we have utilized two key ensemble techniques to enhance our model performance. The first technique we employed is bagging followed by boosting. Bagging involves training the models parallelly and aggregate their predictions. On the other hand, boosting sequentially train the models to improve the performance with each iteration. In this project, we have trained 10 machine learning models. The first one is the logistic regression. It's the method used for the binary classification. We need to determine whether the URL belongs to the phishing or not. And it's a good starting point before we explore into the more complex algorithms. So it has given the accuracy of 93.4%. And the second one is the k-nearest neighbor. KNN is the non-parametric algorithm used for the classification. It classifies the object based on the majority of the classes of their k-neighbors. And it has given the accuracy of 95.6%. And the third one is the SVM, support vector machine. It draws the hyperplane that best separates the URL into the phishing or the legitimate. Once hyperplane is determined, SVM classifies the new URL by evaluating which side of the hyperplane they fall on. And it has given the accuracy of 96.4%. And fourth one is the near bias classifier. It's a probabilistic classifier based on the Bayes theorem, and it will calculate the probability URL being phishing or the legitimate based on the presence or the absence of the certain features. And it has given the accuracy of 60.5%. And the fifth one is the decision tree. It's a tree-like structure. At each node, a feature is chosen to split the data into the two or more child nodes. The splitting process continues until the stopping criteria is met. And it has given the accuracy of 96.1%. And the sixth one is the random forest. Random forest is the ensemble technique. It combines the predictions of the multiple decision tree to make the final prediction. And it has given the accuracy of 96.7%. And the seventh one is the gradient boosting classifier. It's the ensemble learning technique that builds a strong predictive model by sequentially adding the weak learners, and each new model focuses on the error made by the previous models. And it has given the highest accuracy of 97.4%. And the eighth one is the cat boost algorithm. It's particularly useful for this project because it can handle the categorical features present in the URL effectively. And it has given the accuracy of 97.2%. And the ninth one is the XGBoost classifier. It stands for extreme gradient boosting. It will handle the large set of the data, and it will employ the gradient boosting to build the series of the decision tree iteratively. And it has given the accuracy of 96.9%. And the last one is the multi-layer perceptron classifier. It is the type of artificial neural network that is characterized by the multiple layer of the nodes. and it has given the accuracy of 97.1%. This is the review page. User can click on the button if he need to check the URL whether it belongs to the phishing or not. If he need to know more about the phishing, he can click on this button. So this is basically an introduction to the phishing. He can get to know what is phishing, types of phishing, and how to protect himself from the phishing attacks. So this is about the Arivo page. If the user want to predict, he can click on this button. Let's take one example of URL. So this is HTTPS basically. It's secure. Let's see the result. So it's giving 100% safe to use. Let's take another example, which is HTTP, which is basically unsafe to use. Let's see the result. So it has given 100% unsafe to use. So this is the demo of our project. Thank you.